All right, well, good morning, everyone. I share my screen. We are, bring up the right presentation. So today we're going to be an exciting day because we're going to start off with some cartographic presentation tools. The first exercise is going to be showing you how to use these things called data-defined overrides in QGIS, which are super powerful. They basically let you use an expression to control the parameters of a symbology setting. We're then going to look at geometry generators, which allow you to use an expression in how you symbolize and some really amazing things you can do with that. And then I think everyone's pretty excited about the temporal controller, so we'll spend a bit of time on the temporal controller.
Go.
And then we'll get to 3D and finish up with some mesh data, which also involves the temporal controller. So this first exercise I'm going to walk through is kind of a fun one that'll introduce what you can do with data-defined overrides and while making this kind of old style map of Kommune in Denmark. And so this is going to use this thing called a topological coloring algorithm. So you hear the Kommune here all have, there are no neighboring Kommune with the same color. And, but it uses the minimum number of colors to achieve that effect. So I'm going to start out with this. And while this may not have a practical application to your job, it's kind of meant to be a fun way to show you how you can start to use the symbology power in QGIS. So I'm going to start out by adding this municipalities data set to QGIS. And I'm going to use this topological coloring algorithm. So you can see in the QGIS toolbox, there is this cartography set. And a lot of these algorithms are for manipulating QGIS styles, especially in relation to the style manager. But we're going to use this one called topological coloring. And so this assigns a color index to each polygon feature in such a way that no adjacent polygons share the same color index while minimizing the number of colors required. And so we're going to feed it the municipalities layer. And we can just take the default settings, and I'll save this into a Geo package. Oops, I should go into Teams and tell them I'm busy. And I'm just going to call this Kommune colored and click run. So what this does is, if I open up the attribute table, it has all the same attributes, but it added this one off to the right, color ID. So here it computed that it needs 6 colors to achieve this effect where there's no neighboring Kommune with the same color. And so what I can do now is, instead of using the single symbol renderer, use a categorized renderer and choose that new field as the value and click classify. So it gives, again, all the Kommune a different colored boundary using the minimum number of colors required to not have neighboring Kommune share the same color. Of course, this is a quick example because obviously in Denmark we have a lot of Kommune that have multi-polygons, or Kommune that are maybe have a fjord between them and technically do not touch, but this would not realize that. So you might have to go in Denmark's case and adjust some of these colors manually, but it largely achieves the effect. I'm sure there's a couple of errors you can find that don't exactly work, but we're not going to worry about that.
It will not recognize if it's a multi-feature layer.
Right. This is one that's been dissolved. So there's just one feature per Camuna in this case. So it has 99 features in it. I'm going to remove this one here. And one thing, this is using the random colors, which is nice. And a nice little trick with this random colors color ramp is that you can shuffle the colors. So if you don't like the original set that it comes up with, you can shuffle the random colors until you come up with an array that you're happy with. So what I'm going to do now is I'm going to right click on this and duplicate the layer to make a copy of it. So this is going to be Camuna colored copy. And I'm going to, I'll turn off the original. And so what I'm going to do now is, so I could go into each one of these classes and change individual parameters of it. But if I want to make one change to all the classes simultaneously, I can use this master symbol button. So I'm going to click this master symbol button and select the simple fill renderer. And I'm going to change that from simple fill to the shape burst fill symbol layer type. And now I get this effect where I've got a shape burst fill of different colors for the Camuna. And I'm just going to use the set distance method. And I'm going to reduce that a little bit to make it a thinner shape burst. And then I can also experiment with the blur strength, which will again smooth the effect, smooth the blending from white to whichever color it is. So now we have this cool shape burst map of Camuna. And now we're going to create a random dot boundary around these to create that on the map that we're looking at here. You can see that there's this kind of pencil, kind of stippled boundary around the borders of these Camuna. And that's the way a lot of, antique maps from the 1800s and earlier were done, with this kind of stippled effect. So we're going to try to mimic that effect here in QGIS with this random dot boundary. So I'm going to duplicate this layer again, create another copy of it. And I could do this all in one layer, but I'm breaking it up into different layers just to kind of show the different aspects of this symbol that we end up creating. So here I'm going to change this. Yeah, I'm going to select the shape burst fill component, and I'm going to make this an outline marker line. So another one of these options you have in symbol layer type are these various outline settings, which will just create polygon outlines. And if we use a marker line, oops, I had the wrong one set. There we go. Before I do that, I should have, you can always go back and undo things. I meant to change this to a single symbol renderer first before I did that. And now I'll make this a outline marker line. And so the marker line creates an outline symbol for the polygons, but creates these markers, point symbols along the polygon edge. And there's a lot of little settings that we can use in QGIS for where these markers get placed. We're going to use this default width interval, which specifies how frequently those dots are placed along the edge. And we're going to reduce that to a much smaller number. We're going to use 0,1, which will put them very tightly spaced along the boundary. And so we're going to focus on the data defined override aspect of this. So you see these little icons next to different inputs for the symbols. these are data defined overrides, and they allow you to point one of these symbology parameters to an attribute column, or write an expression using the QGIS expression engine to feed QGIS the input for that. So if I click this with interval, you can see I could point it to an attribute column, or I could click edit and open up the expression engine to write an expression for that. So what we're going to do is find the offset portion of this offset along line, and we're going to choose edit for the offset. And I'm going to put this expression in, and I'll explain what this expression does, but it's basically using the concatenation function to concatenate the X and Y for the offset along the line. And we're then going to, sorry, I might have put this in the wrong place. They've just updated this renderer in QGIS, and so they've moved some things around. Offset along line or line offset. I think it's this line offset now. Yeah. Well, if it's not this, I'll try it the other one. All these parts of this renderer, for example, are brand new with this version of QGIS. So this renderer has gotten quite a few new upgrades recently. I think this is the one we want to work with. This offset along line. And feed it this expression, which is concatenating the two values X and Y for the offset between 0 and a random floating point number between 0 and 1 to the 10th power. And I'll explain what that does. And this will create kind of a crazy looking map. Maybe that wasn't. Sorry. I think I was right the first time. Live demos. Well, I wonder if I should pull up a different version of QGIS. The previous. Sorry about that.
Maybe still the dots being so big that you cannot see them because they are overloading each other.
No, it should look a little different.
Okay.
They're still right. They're not really, it's not really offsetting them. Anyway,
Oh.
give me 1 second, and I'm just going to load this up into the long-term release of QGIS when that opens up here. See, you should practice these things first, which I've done a million times, but not in the most current QGIS release.
It's always like that.
Yes. Okay, here we go. Okay, yeah. I'm gonna deactivate that. This is where I meant to select the simple marker component. So when we symbol stacks, you can make changes in a lot of places. And I had the marker line selected originally, and I need to select the simple marker because that's where this offset is that I was looking for. So I think it was just simple user error on my part. So this has that X and Y, and the expression that I was trying to feed it has a concatenation of these X and Y values. So this is where I needed to be. Copy my expression again. Okay, there's the expression. There we go. So now you can see that we get this really crazy looking map because the points are being dispersed along the polygon boundaries. Within a certain tolerance. So what this expression is doing is, bring up that slide. Is that it's gives QGIS a range of 0 to 3 times this random floating point between 0 and 1 to the third power. And so this uses this concat function and the random floating point function to give this array of numbers. And so this value 3 is really what you want to change to control the distance from the polygon border and how far those dots marker points extend from the polygon boundary. So you can put in a larger number there and it will extend the dispersal of points farther into the polygon interior. So it's just one example of how you can use one of these expressions. And so now that I've set this expression for this data defined override, you can see that the data defined override turns yellow, indicating that it's active. And if I hover over it, it will give me a preview of the expression that I'm using. And so what I did before when I had put it in the wrong place, you can also deactivate these from the menu or go in and edit them. And
You
so
control that the point goes inside, not outside.
well, they're going into the interior of each polygon. So I think you could, the other way would be using I guess a negative value for the other. Yeah. So then now this is looking kind of crazy. You simply need to change the size of these markers and give them a more reasonable size. So I'm going to do 0.15 and make them very small. And now you can kind of see that stippling effect happening. And I'm going to use just a dark gray for the color. So 90, 90, 90. And I'll use the same for the stroke color. So I can simply choose pick color and grab that. And so now we have this almost like a pencilish effect along the borders with this offset expression. So we're almost done with it now. Just need to do some final touches, one of which is to turn on a background map. So I could use OpenStreetMap, or I could use one of the Scamquot from data fasooning. And I'm going to set some blending modes and opacity for some of these layers to finish the final effect. So I'm going to turn this Comuna colored on as well. So I have all 3 of these layers turned on and I have the base map underneath. I can turn off the original municipalities. And the random dot boundary, I'm going to use a blending mode on this. So I'm going to go to the fill portion and give this a blending mode of hard light. It'll soften those points a little bit. The shape burst fill layer, I'm going to give this a multiply blending mode, which allows us to see the layer underneath. And I'm going to give this an opacity of 80%. Knock it down a little bit, make it semi-transparent. And then the final bottom layer, Comuna colored, I'm going to give this also a multiply blending mode. And I'm going to knock the opacity for this way down to like 20–25%, somewhere in there. And so this is giving the solid fill to each Comuna. This one is the shape burst fill, which is set to basically be the same number of millimeters dispersion as the stippled dots. And that's because if I go into the shape burst fill settings for this, I set the set distance to 3 millimeters. And if I go into the offset for this, this expression is also using that value of 3, which gives the dots and the shape burst fill basically the same width.
Can you make the shape burst goes versus opaque rather than white?
Yes, you certainly could. So if I go back into the shape burst,
Here you go.
this color can be simply transparent. Or you could also go in and just set it to white and play with the opacity slider on that color as well. So you could go in and experiment with that.
We're pretty nifty.
Yeah, so it's a kind of a, you can see how you can start combining some of these different symbol renderings to create some interesting effects. So that's a quick introduction to data-defined overrides. What we're going to work on next is, I'm going to use this, I'm going to go back to 324. It would have worked in 324. I was just in the wrong place. What we're going to work on next is geometry generators. And this is an exciting thing. Let me just start to demonstrate it, and then I'm going to give you more examples. So I'm going to go into the geometry generators folder. I have another municipalities layer here. This one is not dissolved, so it has all the multi-part, it has a single part features. So for a comuna that has several islands as part of it, each one of those will be a separate feature in this version of the comuna. And what I can do to start looking at what I can do with these renderers is I can, well, first I'm going to give this, just so you can see what happens. I'm going to give it a black fill and a white outline. So we have comuna boundaries that look like that. And then I'm going to duplicate this so I can create a couple different renderings of the comuna using different geometry generator expressions. So on this municipality's copy, I'm going to go in and instead of simple fill, we've already looked at shape burst fill and outline marker line. Now we'll look at geometry generator. And with this renderer, you choose the geometry that you want. So I can render polygons as polygons of different types. I can render them as lines. I can render them as points without changing the data on disk. So I can choose, for example, point for my geometry here, and I can use the centroid function and feed that the geometry. And it now renders each feature with the centroid. And so you can see that all the islands are separate features here because how we have all the small islands off of Bornholm popping out. And if we go down, the thing with centroids is that if you look at
question,
yeah,
how is the centroid generated? Is it the center of the polygon, or how is it?
yeah, so it's a centroid is the we can look at the definition. I believe we go into the expression engine.
Average XY in this case.
Yeah, returns the geometric center of a geometry.
Okay.
And so there can be problems with using centroids because the centroid can actually fall outside the polygon. So we can do another way of this. We can let me duplicate this. And instead of using the centroid function, there's another one called pole of inaccessibility. So it's another one of these functions in the geometry section. And this calculates the approximate pole of inaccessibility for a surface which is the most distant internal point from the boundary of the surface. So this will show you kind of the center of the polygon from that perspective. So I can use pole of inaccessibility. And this takes the geometry and the tolerance. And so when I'm using this, I'm always using this dollar geometry, which is the geometry of each feature that I'm feeding this expression. And I just need to feed this a tolerance, and I'll just give it a value of 1. And you'll see when you're creating an expression like this, in QGIS, you'll always get an output preview, and here the output preview is just geometry point, which is what you want to see. If you have an incomplete expression, it's going to tell you that it's invalid down here. It won't give you a valid preview, but here we have geometry point. So the expression is valid, and I can click OK. And let me just change this to a different marker so we can see what this did. Maybe that wasn't, I'll make them there. So the pluses now are the pole of inaccessibility for each polygon. So you can see that in some cases it's literally very close to the same, but in this case it's a very different spot.
Yeah.
Another thing we could do is so there's a lot of functions in QGIS, a lot of geometric functions. So another thing I could do is try buffers. So I could change this again to geometry generator and keep the geometry type at polygon and go into the expression engine and search for buffer. And there's actually several buffer functions in here. We'll just choose the straight normal buffer, which requires the geometry and a distance, and there's some optional parameters. So if I use a negative value for the buffer distance, it's going to create an internal buffer. Let me see, what was the distance I thought was good to use for this? Yeah, negative 2000. So negative 2000, so it would be a 2 kilometer interior buffer. I'll click OK. And I'm going to change it to a color that we can see, not black. And so now we have the municipalities rendered as an internal buffer of 2 kilometers.
So that's how you made the map of distance to water.
No, actually it isn't. I actually use this multi-ring buffer tool. So there's a multi-ring buffer tool in QGIS that you can feed a constant distance, and I fed it 5 kilometers for that.
Okay.
You could probably do it with geometry generators too. There's really nothing you can't do, it seems. This one, you can see the buffers, it's taking longer to render than the centroid. It's a little more of a computation.
Strain.
To show you related to how we finished up the last course, this is another coastal effect you can create. These are called exponential buffers. So I basically am using an inverted polygon on the land, to just like we created those other coastal effects with, but I'm using a geometry generator and converting the geometry to lines using this expression. And this one, again, is very computationally expensive. It takes quite a while to render, but it's really nice for lakes and things like that to give a different effect to that coastal appearance.
Can you by any means change the say the outline and the size of the polygons? I mean, did you know that there's something called the world mapper where the size of the individual countries are changed according to some attribute value?
Ah, boy, what a perfect segue into the next slide. That
Appreciate
was.
it. Thank you. You're welcome.
There is that. Those are called cartograms in English.
Indeed.
So let me show you that. But here first, this gentleman, Michael Stutz. Well, first off, this map, this was from a New York Times cartographer who at the beginning of the pandemic wanted to show how people were moving out of New York City to Long Island and other, kind of summer home locations in the US to work from home during the pandemic. And he used a geometry generator for this. I think he had the home the business address and the summer house address, and used an arrow symbol with a make line function in QGIS using a geometry generator to create this graphic. So that's another, interesting example. So even the New York Times is using this. This man, Michael Stutz, has a really nice web page where he has some really practical uses of geometry generators, where, in these first couple examples, he had basically metrics of an ion dome boundary, the angle and distance of each edge of an ion dome, points as buildings. You can do lots of crazy things. So this is fun to look at just because you can start to realize the sheer number of creative ways that you can use geometry generators, points displayed as tables in this case. And some of these are quite complex to put together, but you can do some amazing things. And so this web page allows you to download these styles and then pull it into your into QGIS, and then you could see how that is created, that symbol, what the expression looks like. And sometimes you have to tweak the expression to account for differences in CRS. But this is a really wrong. I'll put this in the chat. So he has about 20 examples in here. And this one I've used, it's actually very handy to be able to have these rendering of a polygon that includes the distance and edge of each of the polygons. You can do the same thing for lines. So you can explore that. And Johannes Kroger also has a blog where he's created some more silly ones. He has one that will allow you to create a Lego map of terrain or something like that. The classic Joy Division renderings of elevation and this digital rain. And Topi Chukhanov is a Finnish QGIS geek, and he's done some interesting things with geometry generators too. Gustav Klimt renderings of polygons. So Hans, this is what you're thinking, and this is actually possible with a very new function that just came to QGIS 3.2.4 just a few weeks ago, called the scale function. So here is a cartogram I put together for the QGIS Brewer Group MOLA last week in Odense, and I showed this where you can use the geometry generator against Kommune, and I'm using the heart of this is the scale function, and there's some other aspects I had to do to create an array based on the population density. So I'm scaling the size of the Kommune based on the population density. And I had to kind of come up with a value that kind of made sense at this scale. So I divided it by 500 just so that it worked visually. But yes, you can use geometry generators for that.
Certainly do.
And now
I was just wondering if anyone I'm popping something into the chat now. This world mapper thing, they have their data or their algorithm is open, but I was just wondering if anyone ever took the challenge and put that into QGIS as generators.
I don't know, but I love that site. It's a lot of fun.
Indeed,
Yeah.
it's a darling, definitely, and the source is actually open, so I think it's a matter of time before anyone gets it into something, and QGIS would be obvious.
There's also for, I think it's still there. There's been a plugin in QGIS that someone wrote for generating cartograms.
Mhm.
So a cartogram that World Mapper shows, and what I'm showing on my screen now, is basically where you distort the size or the shape of a feature based on a numeric value. In short, so here they're being distorted based on population density using the scale function. And World Mapper has a lot of other really cool examples of cartograms.
Yeah.
So another function that just came into QGIS at 3.2.4 is a series of wave functions. So now I have a line and I'm styling it with a geometry generator, and you can play with the frequency and amplitude of the waves. So you can see in the expression, I have these two inputs, the geometry, then the amplitude and the I'm blanking, amplitude and frequency. And so I can play with these values to come up with different wave patterns. Some can be kind of mellow and some can be jagged. So that's kind of an interesting, probably a lot of potential for using that to do different things. And there's a series of these now. There's wave randomized that you can play with, square wave randomized, triangular wave randomized. So all the different possibilities there, and that's something that's brand new. So that's something to keep in mind when experimenting with these. If I go into my expression engine for the geometry generator, QGIS has an enormous number of geometric functions. So all of these can be used in QGIS to do different things with geometry generators and other things. And some of the more useful ones, there's one called smooth, for example, that you can use if you have like a jagged line. You can use this with a geometry generator to just smooth it a little bit, make it a little nicer. So there's a lot of things that you can do in here, and it's kind of just up to you to kind of think about what you want to do and figure out a way to do it. There's another there's a bunch of buffer functions in here, and one thing that I've used before is the wedge buffer for photo points. If you have photo points on a map, you can if you have the azimuth of the photo, which direction it was taken in, you can feed that azimuth field into the wedge buffer function and show the wedge buffer would then show kind of the field of view, which direction the photo was taken out in the field. So that's another very practical use of geometry generators, this wedge buffer.
And the view angle of the camera, of the lens.
Yeah. Okay. So that is geometry generators as a quick intro. So now let's think the thing everyone's been waiting for, at least some of you. Have another, this is a project that's stored in a geo package. And this is building points. And this is just building points around my little city, Helsinki. And so we have, how many features in here? 7,000 buildings. And these are symbolized using a graduated renderer. And there's a column for the year that the building was constructed. And so I have them divided into nine classes, red being oldest, green being the newest. And you'll see that there's a filter on here. This data, oddly enough, they used the year 1000 as a no data value, which could be a viable construction date. But Yeah, instead I had to filter out the values that have the buildings had that value of 1000 because it's just a no data value. I thought was strange. So if I want to start using the temporal controller with this, first I can open up layer properties for this buildings layer. And what we get now in QGIS is this temporal tab to layer properties. And this allows you to enable dynamic temporal control for a layer. So I can check dynamic temporal control. And then you have a series of options. So if in this case I have a date field that has the date and time, I can choose single field with date time. And it does have to be an actual date formatted column, as this one is. So it will find that and I can use date. So now QGIS knows the temporal span of this data based on that date field. It's temporally aware. There are other options. You can just use a fixed time range. So if you have data that doesn't have time in the attributes, or let's say maybe it's a raster image, maybe it's an air photo from the year 2000, you can go in here and tell QGIS the start and end date of that layer. So you don't have to have time attached to your data. You can go in and tell QGIS the time range for that layer if it doesn't include it. There's also options for if you have separate fields.
In that case, it would be common for all features or all pixels of the entire scene.
Correct. Yeah. So you could put the time frame in for when the photo was taken, you know, from probably just that day or what have you. Or you know, if you're doing an animation, I think you could set it from that photo is taken at this period of time and then have it expire when the next photo is going to come into the animation. You can also set it up with separate fields for start and end date. So if you have 2 date fields for start and end, you can set it up with that. Start and end and event duration also. You can use expressions and then redraw layer only. I'll show you why you'd use that in a few moments. So you have a lot of options here. I'm just going to use single field with date time, use the date field and click OK. So now I got another icon in my layers panel, a little clock. So now QGIS knows that this is a temporal layer. So now I can go into the temporal controller panel, which is this clock button up here. And it opens this panel usually along the top. Of course, you can dock it wherever you'd like. One other thing I'll show you about the symbology of this buildings layer is that I set there's an advanced button down here, and I set what's called symbol levels. Symbol levels tells QGIS what order to draw the different classes in. So QGIS otherwise kind of, I think, guesses, but here it's forcing it to draw the oldest class first and then the second class. And that means that the green points will be on top of the red points. They'll always be drawn last. So we see the most current building points on top because of this symbol layer. So 0 through X here.
And blend it.
Of course, you could blend it too. Yeah.
Okay.
Yeah, you could do an addition or something like that. Okay, so this first button on the temporal controller is the temporal controller is deactivated by default, so it's turned off. Temporal navigation is turned off. This next one here is a fixed range temporal navigation. So this will pick up on the first date in my buildings layer and the most current date. And this allows you to basically just show one slice of time. So I could set this to, 1950 instead. And then I would just be, it would filter out the buildings that were built before 1950. It's showing just a set range. Or what we're usually interested in is the animated temporal navigation. So here we have a time slider and time controls. So I'm going to set the animation range between 1850 and the current, because there aren't too many buildings before 1850. And then I can just start clicking play, and QGIS will start adding points. And right now, the step is 1 per year, or every frame is 1 year, but I can increase this to 10 years and speed it up. And where years is, you have all sorts of different time scales, from milliseconds to centuries. So you can choose.
And the duration between displaying the individual frames, how do you set that to the temporal scale?
Well, that's this step. So here, every frame is 10 years right now.
Yeah, but the between showing or displaying the individual frames on the monitor,
It
like the
should be.
representational resolution.
Oh, there's this settings button here, this little
Yeah.
yellow gear, and this lets you set the frame rate.
Okay, great, thank you. Appreciate it.
And also has a checkbox for cumulative range. So the default is 1 frame per second. So that's the basics of the temporal controller panel itself. And one thing it doesn't, a lot of times you're setting this up, an animation in the QGIS map canvas. I will say though, that if I go into a new print layout and add my map, if I select my map object in the print layout, there's a temporal controller section. So you can tell a print layout what slice of time to include on the map. And there's data defined overrides next to those. So you could, there's a QGIS Atlas where you can set an Atlas feature, such as a communa, and you could make 99 maps, 1 for each communa, based on some kind of layout template. So you could also use the print composer with this temporal range to create an animation of some kind out of the print composer. But what I'm going to show is how to do it in the QGIS map canvas.
But you cannot export it as an animation straight off the layout.
No, all these tools in QGIS will export a series of still images that you have to stitch together using FFmpeg or GIMP or Photoshop. Or, yeah.
Okay.
I have directions for using the open source GIMP software, and it's quite easy to do. So I'll include those directions so you can export the still images and create an animation from it. So it is also possible though to just create everything within the QGIS map canvas. And so one thing that QGIS, this is all built upon the code that was in the popular QGIS plugin, Time Manager. So I don't know if anyone ever used the Time Manager plugin,
Sure.
but that was what this is all based on. And with that, you had the ability to add a time label onto the map. And this does not include that. But what we can do instead is create a layer for time and use some of the QGIS expressions and variables that come with the temporal controller to put time on the map. So I'm going to just create a new layer, and I'll just create a temporary scratch layer for this presentation. And I'm just going to call this layer time. I will make it a point layer, put it into the correct coordinate system, and I don't have to add any labels to it. So I've got my time layer, and I just need to figure out where on the map I want my time displayed. So I'm gonna use the add point feature on the digitizing toolbar to put a point on the map where I want the time label to go. I'll just put it up here, someplace where there are no buildings, and stop editing. So now I have my time point there. And this is the case where I'm going to use the no symbols renderer because I don't want to see that point. All it's there for is a time label. So I'm going to use no symbols for that point. So that point disappears. And I'm going to switch to the labels tab and use single labels. And I'll open up, I don't have any attributes for this layer. So I'm going to open up the expression for my label. And I'm going to search for time in the search box here. And you'll see there's variables map end time and map start time. So I can use these variables to put time on the map. So I can, I'm going to use map start time, and that's the start time of the temporal time range for the current frame in QGIS. So my label is going to be the map start time, and you can see down here the preview is the year, month, day, hours, minutes, seconds, and I don't need all of that. I'm playing 170 years of buildings, so I really just need the year on there. I don't need hours, minutes, and seconds. So there is a format date function that I can use to set this up. I'll put my cursor in front of that map start time variable and use the format date function. And the format date function has, it takes the date, which is my variable, and then you can set the format. And the format there's all these great formatting settings. So I can choose whether I want the day as a number with a leading 0 or the day as a number without a leading 0. And if I want the month as a number or the month abbreviated or the long localized month name. So you have all these options here, and you simply have to set that up in single ticks after the comma here. So I want the year as a 4-digit number here. So I'm just going to put 4 lowercase y's, another single tick, and close my parenthesis. And you can see now the preview is down here. And you could do other things. I could type some more text in here, and I could put year equals and use the concatenation operator to make my label like that if I wanted to. So you can set up the label any way that you would like.
I use double pipe for concatenating.
Yes, this little down here, these are the common operators at the bottom, and this one with the double pipe is the string concatenation.
Okay, great, thank you.
So you can just put that between different pieces of text. And then, of course, as we saw with the Comuna antique boundary map, there's also a string concatenation function, and you can use that function to put together different pieces of text. There's multiple ways to do it, but this is very quick for doing something like a label. This expression engine is the secret power of QGIS. With those data defined overrides and all the functions you have in here, it's kind of becoming its own language in a way. It's really powerful.
How do they work in relation to Python and in relation to the tools of QGIS? Are they more or less the same language, or are they different?
Yeah, this follows more the syntax behind SQL.
All right, got it. Makes sense.
Okay, so now I have my date on the map there, and it's just a little too small for my preference. So I'm going to make it bold and increase the size so that I can see it. And you can also then, any of the text formatting functions are available to you here. You know, you could put a drop shadow under it. You could put a text buffer around it, all of those sorts of things. So now I have time on here. So now if I use this slider to scrub through time, but it's not updating, is it? Well, there's one other thing I didn't do. So remember that redraw only. So I need to go into the properties for the time layer. And I need to enable dynamic contemporal control for this layer. And I need to tell QGIS to use this redraw layer only option. So this forces QGIS to just automatically redraw this layer every map frame. And it's using that map start time variable. And so it'll just force it to refresh that variable to the current time each map frame. So you do have to set up this redraw layer only, otherwise the label will not work. So now you can see I'm at the year 1260 here, and I can move forward until we start getting some buildings. There we go. So you can also just scrub through time using this. And now that we have the label, you can actually see what year it is as I do it.
It's so cool.
Yeah, it's very cool. We're at the top of the hour. Let's take a 5-minute break and then we'll just continue so everyone can get a hot cup of coffee, and we'll come back in 5.
Thank you. Appreciate it.
While everyone's coming back, just to show you some of the things that are possible. Kind of, these are absurd, but still amazing. Just to think about what you can do with this. So this friend of mine, Keith Jenkins, has done some fun things with QGIS and the temporal controller.
It's a wave.
Yeah, exactly. And you know, there's just a lot of this. This was a fun one where he made Madagascar go on a trip around the world. Madagascar towards the Atlantic Basin. And just silliness with QGIS, but it kind of lets you know like what the range of possibilities are. It's quite endless what you can do. And for next Christmas, there's also you know, people were playing around with this during the holidays. So it is there's a full range of potential here.
Is time used for anything else but animations? So the time possibilities, are they also implemented in some of the analytical possibilities?
Not yet. I mean, of course, it's simply data. So I think from a data perspective, I think a lot of the functionality is already there for now. You know, you can select features by time like you could any other attribute, and slice and dice it to come up with different metrics and statistics. But do you have some specific thoughts on that?
No, I just think like temporal overlays and temporal bufferings and anything we can do in relation to a temporal topology would be of interest.
Yeah. Well, maybe, yeah, I haven't seen a lot of that. I think the animations are the most popular thing, especially on, you know, on social media where it kind of is eye candy. But I'm sure that there are people working on that sort of thing, especially with, I think transportation, routing times and things like that are also.
Agent-based modeling has an obvious temporal component.
Yeah, any kind of movement.
But is it possible to like prepare some data for this temporal view? Like if for instance, I have an attribute table for a point, and then maybe 10 columns, one for each year, then assign or change the attribute table to the date format you just showed. Would that open up for the possibilities to display data in this way?
I think you'd want.
How do you prepare the data basically?
Well, this data wasn't prepared. This was just acquired, and this data. simply has a construction date attached to it. Let me see. Oh, that's time. Oops.
It's BBR.
Yeah. Or Inspire, I think. So this had a construction date here. And so what I did was I actually just took the year out and created this year column. Well, I think, yeah, I created a true date column and then a date column that just contained the year for this. So this, some data does have dates and timestamps with it. But if you were going to show like point over time, I think what you'd want instead is, I think you'd want to flip it where maybe you had a series of records for that point with just a date column, and then for each record you'd have the different dates for that. So maybe instead of having 10 fields with 10 dates, you'd have 10 features with the date for each in one column. Does that make sense?
Sorry, I was thinking on how to present sewer overflows. That's one of the things that's very hyped these days. So we're having a lot of calculations made from each overflow point in the sewer system. And one point I'd like to show is how it varies over the different years, obviously because of the difference in the rain.
Mm-hmm.
But then I'd like to make a little animation of these are the overflows of these last 10 years. So at 1 year you don't have any at all, and then other years you have plenty and all sorts of, yeah.
And are those point data or are they polygon? What's the geometry?
Point data.
So the location where there was an overflow.
Yes.
Yeah.
And then an attribute table with containing the different volume for each year.
Okay. And you
So
can size the points by volume.
Yes. Yes. So one column being 2020, and it has all the volumes for each point, and then another column between 2019 and so on.
That's a good question. I got the same.
Yeah.
What I have is the square net for the entire country and each dot has the number of people that lives in each cell as a point back in time. And I want to show the temporal change for the individual points, which are stored in attributes.
Right. Yeah. It might be just a matter of restructuring the data so that you have a single date and multiple copies of each cell by date stacked on top of one another somehow, so that you could have the different cells come on or the different points come on during that time stamp.
That's an option.
Because it is more straightforward to use this when you have a single column for the date that you're pointing to, so that or a duration. So for buildings, for example, the way that the options you have in the controller is a single field with date time, or separate fields for start and end. So you might have to, you could also certainly have just filter the data, have different duplicate copies of the layer and filtered by the column, and then so for each one you'd point to the date column that, so you'd have, the one might be the date column for 2020 and one might be the date column for 2019. So you might just have multiple layers, because you can have as many layers in here as you need to have, and they can each be temporarily enabled. So you might just have to kind of pull the layer and you have two different copies of it to so that each one could point to its column.
Could you make these dots size difference in size based
Oh.
on, let's say there was some square meters on the data saying, so this is the biggest buildings who had the biggest dots and so on.
Yeah, so
Again, I'm thinking about my overflows.
yeah, so here I'm using a graduated renderer, which is you can use it when you have numeric data, and I'm using the method of color, but you can choose method of size. And then instead of choosing a color ramp, you choose small dot to big dot based on this size. So you'd use the same render, but just the other method. So the other thing you can do in here, since if you want to make an entire animation out of this, is you may want a title and a legend and things like that also added to this. And so one thing you have in QGIS are these things called decorations. So if I go to the view menu to decorations, I can add, for example, a title label to my map. So I can enable the title and I can call this Helsinki and click apply, and it adds a title up here. And I can, have all the same options I have for labels. So I can make this a bigger font and maybe make the font white since it's on a dark background. Click OK and apply.
Could you apply the expression here to tell the year?
Yeah, you certainly could. So you can insert or edit an expression.
That's it. That's it.
Yep. So yeah, you could have this
As
be
an
the-
alternative to your point.
Yep. Great idea. And then for a legend, in this case, I just created a print layout and took a screenshot of the legend. And so it's a separate PNG or JPEG. And I can go back to the decorations here and choose image. And I can browse to the course data. Let's see. And I have this legend JPEG. And then I can choose for any of these decorations, you get to choose the placement where you want it to be. And then you can choose margin from the edge. So I can put some distance from it, and you can also choose the size. Click apply. And now I have a legend there, and I could put it in the middle of the hind there with a little. Like that. So it's in a good place on the map. And now you have a title, a date, and a legend. And so, and again, you can, start scrubbing through time and see the different buildings. Here I might choose the animation range from 1850 to 2020, so that I'm really showing the period when there's the most data on the map. And if you were then wanting to export this as an animation, you click this little export animation button off to the right. And this is going to export a series of images from 0001 up to whatever the last image is, just numbered sequentially. You can name this prefix anything you'd like. And then you just simply choose a folder for those to get dumped into. And you can choose during, the map canvas extent. You can choose the date range. You can set a different step and time frame here and export it, and it'll export out all those still images. And then you can, one way, it's probably the most approachable way to do this is in GIMP. And it's quite straightforward. I don't know if anyone's used GIMP before, but it's an open source version of Photoshop. Essentially, it's an image manipulation software for photographs and things. And you can, just 3 steps. You go to File, Open as Layers, and you select all your images. and it will open those all. And that can take a few moments depending on how many you have. Usually it's several hundred. And then you go to the filter menu, animation, and optimize for GIF. And then finally you export as. So it's only those 3 steps to create an animated GIF. And when you choose export as, this is the window that will come up, and you can choose, as animation. You can choose to loop forever. And you can use this delay between frames to kind of figure out how long you want the animation to last, because it allows you to specify how long each frame is going to last. And so you can compute the number of seconds that the animation will be based on that. And click export, and you have an animated GIF. It's quite straightforward. And I gave a talk at Coet Day. I know Hans saw last year. This is what the animation for Helsinge can end up looking like. I just have a different base map on this one, but otherwise it's largely the same. And you get all the kind of see how the city grew through time. And there's other things you can do. This is data created from researchers collected, had banded turns with GPS units on them. And this shows the migration. They have like 2 summers per year. So they follow summer from the North Pole to the South Pole and back. And they migrate farther than any other species. It's phenomenal. So you get to see the speed at which they migrate. It's like 80,000 kilometers in their lifetime or something like that. And so here is another use of the temporal controller. And if you were to use the print layout, I was thinking you could also have the globe moving underneath them. You could get even fancier with this. And then for COVID-19, this is another version of an animation. So in this case, I joined the data, and I actually have, ends up being a large data set because I have multiple copies of each communa. It's one for each date, and then I have the date attached to it, so it knows which polygons to turn on for the current frame, and they're all symbolized by the rate of COVID-19. So this is another example of creating an animation from the temporal controller with a different kind of data.
I know we're going to 3D in a moment, but will the elevation also be an option? Or the heights?
Animation in 3D?
Yeah, when you're animating these things in 3D, you could then instead of calling changing the size and the color, could you change the height of the point and the height of the polygon? So watching in 3D will go up as pillars.
Yeah, I don't see why not, because you can you can set up 3D rendering. I see, but there's a 2.5D renderer in QGIS that might work for that. It kind of extrudes features kind of 2.5D within the main map canvas.
Let's play with it. It should be an option.
I don't think there is. Don't think the 3D panel supports time that I've seen.
Okay.
So I don't think so, but it's an interesting idea for sure. And there's probably a creative way.
I did it in Rhino once.
Mm.
But that's a cat, so it's a different thing.
Oh yeah, the 2.5D renderer is only for polygons. But you can, for buildings, for example, we're going to go into 3D next, and there's a 3D tab in a layer property now, and you can set up separate 3D symbology from the 2D symbology as a transition into that world. And so it might be possible. You'd probably have to do a little hacking to figure out how that would work, but
it's the name of the game.
Exactly. That's where the fun begins.
Exactly.
So that's the temporal controller. And then let's move into 3D and then we'll get into mesh.
Sorry, if before we move in, some of the examples you give were the hurricane examples and your biking examples, they're like dragging a tail behind the moving objects.
Yes.
Can you put that into I don't do it now, but can you put that into the collection of examples?
Yes, I will.
Appreciate
So
it. Thank you.
yeah, so Hans is talking about I made a temporal animation of a Sukeltor, and so I have this kind of a temporal symbology where this kind of glowing worm extends, and I actually change it whether we're on asphalt or gravel. So we'll go into a gravel section down here and the symbology changes. And so you can, this is an example of temporal symbology, and I will include some screenshots or explanation of how I did this. It took some experimenting, but it's kind of fun.
Indeed, it's beautiful.
And then this uses the temporal controller and geometry generator. This clock is a pretty complicated geometry generator but it's a really cool way to depict time when you're doing this kind of thing. So I actually borrowed this from the Topi Tupanov, the Finnish cartographer, and because he has this posted. And so one of the links I gave you, actually this is available if you go to open up the style manager in QGIS and go to browse online styles, this is one of the styles that's up there for this clock. I had to do a lot of tweaking to it to make it work in UTM. It was huge, and I had to figure out how it was built. It's built of a whole series of different things, but I will try to give everyone that too. So
Appreciate it. Thank you.
You can do some cool things. Okay, so with 3D, what's my project that I'm opening here? I have a couple of different projects. I'm going to show you Mount Rainier, but there's also a 3D project for Moons Klint that you can play with to work with a Danish example. This is just a spectacular 3D scene, and it's a nice, small, tidy data set. So I like playing it because it's beautiful. This is a 4,000 meter tall volcano outside of Seattle in the US. And so if I want to create a new 3D map view, I simply go to View, 3D Map Views. And I create a new 3D map view. And this 3D map view is a panel. And especially if you're on a small laptop and you try to move this 3D view around, it can get kind of annoying. It kind of tries to dock in different places. So you have to kind of be careful as you try to resize it. So this gives me a chance to show you a new feature that just got released with 3.2.4. And it's this little button off to the right, Dock 3D Map View. So it lets you toggle between undocking and docking this view. So if I have it undocked, I can move it anywhere and it's not going to try to dock anywhere. So that was a much needed improvement to this. It's brand new. So now that I have my 3D map view, there's this options, kind of a settings button that will allow you to configure the 3D aspect of the data. So I'm going to tell it not flat terrain, but I'm going to get my elevations from a raster layer. You can also choose mesh or an online source. So I'm going to choose the DEM as the elevation, and I'll just click OK. And now we have this navigation panel that you can dock and undock. You can toggle it off and on from this button. And I can use this tilt down to start tilting this into a 3D aspect. And then this compass rose can be used to rotate around the scene. And then these, these zoom in, zoom out buttons. You can also use your pan and zoom, and you might have seen that a couple little white seam lines right there showing up. You can fix this if this happens. It's basically tiling the 3D scene. And if I go back into my options, this option for skirt height can be used to control that. This basically creates a taller skirt between those cells and helps blend them together. So if I increase this value for skirt height from 10 to 100, those will, those kind of artifacts should disappear. So sometimes you have to experiment with that. That's it. This is basically a viewing window. So not a lot of analysis yet, but this is still a fairly new feature in QGIS. And this is one area, whenever there's a new major feature like this, 3D views are quite complex from a development perspective. So there's new functions being added to this every release of QGIS. It's growing quite rapidly. For example, this little toggle that I just showed you. You can also, there's a measure line feature here. So you can measure within the 3D scene, and it'll give you the horizontal and vertical distance. That's about the only analytical capability it has at this point. It'll also honor map themes. And if you want to create an animation in this environment, you click this little animations button, and you get this time slider down below. And so you can basically create keyframes, which are basically camera angles. So I could click here to add a keyframe and say at 0, this time 0, I'm going to start here. There's already, yeah, 0 and 5 is already there. I'll just enter this at 1 second, and then I can start, rotating the scene to the next view perspective, or zoom in and create another keyframe, and just keep creating those as you want to navigate the terrain. Sometimes you'll get in a situation where it has to reload all the tiles. It's rendering the scene right now. This is kind of a small data set. It usually doesn't take this long. Let me just go back to the full view to continue this. But you basically just add the keyframes as you want to have the viewer fly through the scene. I can add one at 3 seconds. This probably is not going to be a very nice fly through, but now I can go through and click play, and it will move between the keyframes that I set. And if I then wanted to export this, it's the same way you would export it out of the temporal controller. You click export animation frames. It's going to do the exact same thing. It's going to create a series of still images that you dump into a folder. And whether you're doing this from the temporal controller or the 3D viewer, it's good to just have an empty folder just for those still frames, to create a new folder for it. And you can choose other settings here and export those still frames, and then stitch it together in GIMP or FFmpeg or something like that. FFmpeg is a command line open source software that gives you more options. You can create an MP4 or an AVI file, for example, with FFmpeg. And it gives you a little more control over some of the parameters, but you have to be comfortable with the command line environment to use it. You can also just export still frames. So if you just want to export, I have this measure tool turned on, it keeps opening up. But you can, if you have just a scene that you want to export as a still image, you can use this button to do that. And there's this new feature, export 3D scene. This allows you to save this out in a format that you could use Blender or other software to open it up. So Blender is a really powerful open source 3D rendering environment. People use it a lot for the video games and film editing and things like that. But you can also use it to work with 3D scenes exported out of QGIS and do more with them in that environment. And then another nice new feature that came along in this version of QGIS. Before this, it was a little, as we would say in English, hinky. It was kind of a funky setup. You would open up a 3D view, and as soon as you close QGIS, it would disappear. And so you'd have to do everything you wanted to do in that 3D view in that session and be done with it. But a new feature, which is very needed, is that there's now a manage 3D map views. So basically a manager like you get with the print composer. So there's a print composer manager for different print layouts. And now there's a 3D map views manager that you can use to do things like rename. I can select this one and rename it. And so you could have multiple 3D views. I could duplicate this. And it'll create a copy of my 3D view. So you can have multiple views in the same project now. And and then QGIS can crash on you. But when you do that now, the nice thing is that you can, if you have multiple 3D map views, it will list them here. So you can open up QGIS and go to this option just like you would with a print layout and just open whichever 3D view that you want to open, and it will open it up for you. So it's quite nice. It's getting better every release. And this also supports mesh data, and it also supports point clouds. So you can bring all of those. You can bring vector data, raster data, mesh data, and point cloud data all into the 3D environment and work with it. And it's also supported in a print layout. So if I have a new print layout, there is a button here on, this is how you add a map to a print layout, and this is how you add a 3D map. So I obviously QGIS has crashed and I don't have one, but I could add a 3D map to my print layout, and then I could copy the settings from one of the 3D views in my project. Basically say I want this 3D view to be put onto my map, and it would, you could copy the settings from how you left that, but you can also use these camera settings in the print composer to change how the angle or the orientation of the camera in that 3D scene to something specific. So that's nice. You can also include them in a print composition as well. Okay, so let's finish up with mesh data. So just to introduce this a little bit, because mesh data is kind of a new phenomenon. It's kind of a hybrid data model, as I think of it. It's a collection of vertices, edges, and faces. So if you've ever heard of this data format, it's an Esri data format that started out, I think, with Esri TINS, which is an acronym for triangulated irregular network. That is a form of mesh data. And so it can be very efficient for depicting terrain. And for one thing, because if you think of a DEM or a raster elevation data set, you have all these pixels at whatever resolution they're at. Even if the terrain is kind of flat and homogeneous, you still have all those pixels. Whereas if you represent that as mesh data, you can kind of have bigger triangles for flatter pieces of terrain and more small complex triangles where you have a cliff or a steep hill. So you can, it's very efficient for that kind of data. It's also used a lot with weather data, which is what we're going to look at. And some hydrological modeling softwares will output mesh data. So actually sewer overflows I'm sure that there's a way that you could incorporate mesh data, because I've seen examples of using mesh data to show data output from a flood modeling scenario, or blue spots where you see the water inundation over time with the mesh data. I don't have an example of that, but you can find some online. So there's
Like
several.
like Civil 3D and these pieces of CAD software, they're all using triangle networks.
Mhm. So there's different structures of mesh data. And so what we're going to do is look at some data from different storms in Denmark. So we're going to look at the December hurricane from 1999, which I believe is the highest wind speed ever measured on Danish soil, unless that's changed recently. And I have data for another storm in Bodil. All this data comes from Copernicus. So this Copernicus Climate Store has this fantastic data set, this ERA hourly data on single levels from 79 to present. And to me, that's one of the most exciting parts, is you can go all the way back to 1979 with this data, and it covers all of Europe. And in some cases, it's global. So you can go back, in our case, back to 1999 in Denmark and acquire data for a specific storm and show it in QGIS. And the data has different components to it. So mesh data can have a wind, a rain, a temperature component. And so you can choose which components you want to download with the data from the website. You can also choose the time period, and you can choose the spatial extent. So you can set all that up and then just download it. So it's a really nice interface for acquiring data. So let's start looking at this in QGIS. Do I have a project for this? No. So here's the mesh data. Will have this icon next to it in QGIS, this kind of mesh triangular icon. And I'll add this to the project. So first off, we'll see that there's different, in the layer styling panel, we have different tabs for mesh data than we get with vector or raster. And if I go to the layers panel, you'll also see that QGIS already knows that this is a temporal layer. It's already temporally enabled. So if I go into layer properties, QGIS already knows that this is from December 2nd of 1999 to December 5th of almost December 6th of 1999. So QGIS automatically recognizes it, that temporal data is embedded in the format. And so I can, if I go to this first tab, I have data for wind, temperature, and precipitation. We're just going to look at wind for this storm. And we have this two components. We have this, what's called contours. So this tab here, which is basically the raster component. It's going to show the wind speed. So I can go in here and widen this, and I can choose a specific color ramp to show the contours. So I'm going to choose red, yellow, red, yellow, blue. And I'm going to invert this. So the higher wind speeds will get a brighter color. And then I can go in and I can even change the stretch of those colors and enter a smaller number. So the higher wind speeds get identified a little bit more. And let me add the, yes.
Good. I just try to click while you're presenting. When I open the layer, it's distorted, like the coordinates or the projection is. How do you fix the projection so it's nice and square? Do you know?
Yeah. If this is in geographic coordinates, so, and even my QGIS says it's an unknown CRS down here. So one thing to check is to see, does QGIS know what projection this is? No, it doesn't. Sometimes it doesn't read the CRS information. So in this case, I'm going to go into the layer properties for this layer, go to the source tab, and tell it that it's in 4326, which is the latitude, longitude, unprojected geographic data. So it's not in UTM.
Okay.
And then I'm going to tell it to set the project CRS from this layer. But it should look like this. If you had it reproject, if you had your QGIS map set as a default to 25832, yeah, it would probably look strange. And hopefully that's what's happening.
I believe it is, yes.
So now there's another, I just have a countries layer in here. So let me add countries to this and add Denmark. I think, yeah, we can.
If you set the frame to UTM-32, then we'll line up, wouldn't it?
Yep. So yeah, we can now just set the Denmark and this countries layer are in 25832. So I can right click on those layers once I've added them and set the layer CRS for the project to this. So now that we get Denmark and Scandinavia looking the way we're used to seeing it. I'm going to zoom into this portion. So we have a little bit of context around Denmark and we can see the storm arriving when it comes in. And I'm going to go back here. So I've got the contours data set up. There's another component of this, which is the vectors. And this little arrow here is grayed out right now. And so I'm going to click on that and enable the vectors and then go to the vector tab to configure those. And so I can go in here and choose, a dark blue for the color. I can also do some nice things with the arrows, like display on a user grid and increase the spacing of this so that they're not so dense, because the default settings for these vectors can overwhelm the map quickly. And with these arrows, we can also go down here to arrow length and tell it we want to use scaled by magnitude, which would scale these to the magnitude of the wind speed. And I'll knock the scale factor down to 1. So the size of the arrows corresponds to the wind speed now. And I can make them a dark blue so they blend in a little bit more. And now I can open up the temporal controller and go to my animated temporal controller button here. And I can start scrubbing through time. This data is a little larger, so there's a little flicker as you go through, but I can start to see the storm approaching. Now we're getting very high winds. And you actually get to see if I go back one frame, actually see the vortex here. So the arrows are just one symbology option for vectors. There's also streamlines, which with this kind of data typically overwhelm the map. So I haven't used those much. What I really like is the traces. The traces kind of gives that kind of nice visualization to the wind as it's approaching. And so now we can, step through and see as that storm passes over Denmark. And we've basically got the symbology set up now. It was, fairly quick to do with the vectors and the contours, and you could then treat this like any other temporal data set. You could do all the same tricks by adding a date stamp on there with a layer, using the same way we did with Helsinki buildings. You can set the step. Here we're using 1 hour. This data is collected every 6 hours, so 4 times a day. So we have, several periods of time between over the 3-day period that it takes the storm to pass over. But you can play around with the step, and then you would export this out as an animation the same way you would with Helsing buildings. It's also possible to do other things. You could, for example, simply turn off the contours and just have the vectors. And then you could do something like turn on a Google satellite base map and put the wind vectors as white. Show it that way.
But Kurt, these individual vectors here, they're going from where to where? What is the basis? I know it's the magnitude, but how is that magnitude calculated?
I don't know how the renderer, the traces renderer is computed. I don't know the algorithm behind that.
Okay.
But it has something to do with, there's these settings for the tail length. So you can set the tail length for each stream, the maximum tail length, and you can set the particle count so you can make them sparser or denser. You can also choose color ramp shader with this, but in terms of how they're computed, it has to do with the wind speed values for basically every cell across the contours. And those are in meters per second. In this data set, I believe I'd have to go to the Copernicus site to make sure of the units, but I think it's in meters per second, the values. So this is one example of mesh data. This is what it might look like if you brought it in and animated the whole scene from beginning to end with a date stamp and a title. And then what I just showed with just white traces over a satellite image. Do I have, which presentation is this? Yes. So this is another storm Bodil from 2013. Followed a similar path. And there's also DME has lightning data that you can download, and it's it has a timestamp with it, and that means that you can then bring in lightning data. And I'll also share how these points fade in and fade out with time. It's a little more involved than we had time for in this short course, but I'll send you some screenshots of how this was done, or some animated GIFs of how this was done. But this is incorporating lightning data along with the mesh data to see where that was, where the lightning was hitting during the storm. And here I broke the timestamp up into the date and then the clock to differentiate between those. Yes. And just going back to 3D, I just saw the slide, and this is worth. There's a plugin in QGIS called QGIS to 3JS. It's a really nice plugin that's actively maintained, quite intuitive to use. And the benefit of this is that it creates a 3D scene that you can view in a web browser. So you can view it locally, and it performs really well. The plugin basically creates all the JavaScript and HTML for the 3D view, and then you just point to that index HTML file and watch it in a viewer. And if you have a web server, you can put it on the web server and have a 3D view that people can interact with online. So this is another important plugin related to 3D. So yeah, we went through a lot in a short period of time, but I will also now send you detailed step-by-step instructions for what I showed, along with the assignment and the recording from this, so that you can go through all those examples. And just like last time, I also have short YouTube videos on each section that go into a little more detail. So you can watch those as well. Any questions on this? We've had some good discussions so far.
Nope.
Nope. Okay. Well, good. So you don't have to create an animation with the assignment, but I encourage you to play around with that. So you can definitely send me one of your animations if you want to. And yeah, I'm sure with the temporal controller, there's a unlimited uses for that, because almost any data can be used with that. And a lot of data includes time with it automatically. But if you have any questions on specifics around using that with your own data, feel free to email me and I'll try to think about it and give you some advice.
That means if you have, say, a classical GPX data set with a number of dots at locations at different times, you could actually make it move with a tail behind it.
Yeah, you could.
Oh, great.
Because that's what the SQL Tour data
Yeah.
was, GPX.
Yeah.
I think I put it in a GEO package eventually, but the source was GPX. Yep. So you absolutely could do that. And I just collected it with my GPS watch.
I have some of these data sets with camera-based trackings, which are like 30 hits per second. So they're very, very dense in both temporal and spatial terms.
So yeah, I mean, everything happens in time and place. So time is equally as important as place for a lot of the phenomena that we're mapping.
If you want to export stuff that you have in PostGIS, and how would you do that? You wouldn't do that as a shapefile, or what would be the obvious choice?
Export what into PostGIS?
I have a data set in PostGIS and I want to export that example given and send it to you.
Oh,
what would be the most obvious?
Yeah, I guess you could just dump it out as a SQL dump file.
SQL, yeah.
And I could pull it into PostGIS myself.
Hmm.
Yeah, or you just if you have access to it in QGIS, you can export it in any format just by right-clicking on it.
Yeah. But just if you do it as a shape, you know the date field is distorted.
You export it as a GEO package, because
Okay,
then
great.
GEO package
Okay, makes sense.
has a true date format that it will recognize, and so it'll pick up on the PostGIS.
Mm-hmm. And GeoPackage is like it's both data and rendering embedded, and it can be rendering of more than one layer.
Yeah, so it's a small spatial database. So it can include multiple layers, and it can also include raster. You can store symbology in it. And
so it stores both the data and the topology at the same time.
It can. It doesn't necessarily, but it can. So in QGIS, there's a tool in QGIS you'll find in a toolbox called package layers.
Mm-hmm.
And if you have a QGIS project with a bunch of layers in it, you can run package layers and export all those layers into a GEO package. And there's a little toggle on that tool to include symbology. And so if you have that checked, it will pull those into a GEO package with the symbology. So that if you give that GEO package to someone else and they pull it into QGIS, it'll come in symbolized. And then the other thing with GEO packages is that you can also save a QGIS project into that GEO package.
Yep. So
all of that. And you can also save QGIS projects into PostGIS as well. So
check.
Yep, all of that is possible. So it can, if GEO package is a nice little package that can have everything. Great. Well, thanks. This was a great class.
It was a treat, certainly. Thank you.
Yeah, fun. So look forward to seeing what everyone produces.
We're working on it.
Yes. Okay.
All right. Thanks a lot.
Yep. Hi.
Yeah. Thanks,
Bye.
Aaron.
Bye.
Bye.